Welcome back. So in this video, we would cover some more nuances of MCP, Model Context Protocol. In the last video, we saw how to connect MCP servers from our ADK agents, and we connected couple of MCP servers, which are the reference servers from Anthropic. So in this video, we would see how to build our own MCP server. In the previous video, we used standard IO, STDIO protocol of MCP server. And in this video, we will build an MCP server and then connect to that server using the second protocol, which is streamable HTTP. We are going to build a RAG application. RAG stands for Retrieval Augmented Generation. So at the end of this video, we would cover two primary topics. One is how to build MCP servers on our own, and also how to build a RAG applications, right? And we would use ADK. Our agent would be an ADK agent, and it would connect to the MCP server through streamable HTTP protocol. So let's start. So this is what we are going to build today. So we would have the ADK agent that would interact with our MCP server, which at a backend we would have a vector database, which we are using ChromaDB here. And altogether it is called the RAG application. And as you might have seen in my previous videos, once we have the application, we can run it in three different ways in ADK. We can have ADK run, which is a CLI way of running the application, or we can use ADK web, which is the inbuilt UI interface provided by ADK, or we can use ADK API server, wherein this application will be available as an API, and then we can create a Streamlit UI to access that API server. So if you want a customized UI for our application, then we can use ADK API server. Otherwise, we can use ADK web or ADK run to test our applications. So since we are building a RAG application, which stands for Retrieval Augmented Generation, let me briefly spend a couple of minutes on how RAG works. So in a RAG application, initially we split the documents into small chunks that are embedded using an embedding model, which we store in a vector database. In this case, we'd be using Chroma. And then subsequently, when user asks any query, so that query is again converted into a vector using the same embedding model. And from the vector database, initially we get there is a retrieval process which would give some documents which are very close to the query, and that parameter you can set yourself. If you say 3, then it would basically give you 3 chunks, or if you set the parameter to 5, it would give you back 5 chunks which are closest to the query. Once the retrieval process is done and you have the chunk, then the query and or retrieved chunks are sent across to the LLM. LLM would then find the suitable response, articulate that, and send it back to the user. That is how RAG works. So let me demo the application first, and then I would walk you through the code. So this is what we are building. We are using ADK Web to bring up the UI provided by ADK. We are building this RAG application, which has the MCP server, and this has the 7 tools, right? Which is one for RAG query, one is for listing the repos that we have, one is to get the info about a repo, one is to create a new repo, then we have something to delete repo, and then we have something to add documents to the repo, and finally to delete documents from the repo. Now if we go to the tool and ask it list the tools you have, so these are the tools that we have. As we saw in the PPT, we have the 7 tools: RAG query, list repo, get repo info, create repo, delete repo, add document, and delete document. Right? Now, if you ask it, list the repos that you have in a readable format. So it is calling that list rag repo. So now you see the existing repo in the vector database. It has HR policies, KDB repo, and all that, right? So let's try a couple of more tools. If you say add a repo named, say, new repo 1, okay? So now it is calling the create rag repo tool, and it has created the rag repo, right? Now if you say list the repos again in a readable format, so we see the new one that we have created, right? Now if you want to delete a repo, say for example we want to delete this repo called repo1, delete the repo1. So now this is calling that delete rag repo, and then it has deleted that. So if I say list the repos, so now that repo1 is gone, right? And as you can see, if you see in the pictorial diagram, so this is our rag MCP agent. It has access to these tools. So when we ask for listing the repos, it called this tool, and then this has responded back, and then this rag agent, then it gave the response back. Similarly, when we say delete, so it basically called the delete tool, and then delete tool responded back, and then we got a response from the rag MCP agent, the root agent, right? Similarly, if we ask list the files in the repo literatures, so it is calling that tool get rag repo info. So it has only one document, which is the novel A Tale of Two Cities, right? Now let's try to query something in this document, because this document is now vectorized. The original document was a PDF document which got vectorized and saved in the Chroma DB. Now that the document has been vectorized, if we ask any query, it should be able to quickly find it. So if you ask list the main protagonist of the story, so it is running the rag query. So behind the scene, this query is getting vectorized and then is getting queried against this document, which has been chunked into, multiple small documents, and then got vectorized and saved in the vector database. And then this is what the response is based on the provided text. So it is going against this novel, A Tale of Two Cities, and so main two characters it has listed. Yeah. If you ask who was Dr. Bennett, so this is one of the key character in that story. So it has been able to describe who was Dr. Manet. Rag, the agent is supposed to give the response only if that knowledge is available in the existing knowledge base. So if you ask something like, where is Bangalore? And as you can see, it is responding back saying, I'm sorry, I cannot answer this question because it is not in the knowledge base, yeah, RAG database. So this is how RAG works. So let me get into the code now and show you how we have coded the MCP server and the RAG agent. So here we are in the Google Colab. The first you need to install the packages that you need to run this application. So what you need is Google ADK, ChromaDB, sentence transformers, because we are using embedding to embed the document to vector, and then fast MCP for creating the MCP server. And here we need to install these packages. The first one is for PDF, second one is for Word document, third is, and the fourth one is basically for reading an Excel file, and text anyway it can read. And then finally Streamlit if we need to create that customized UI, right? And Light LLM I am not using here because I will be using Gemini 2.5 model. But if you are using anything other than the Google model, because we are using ADK here, you need to use Light LLM. If you want to call, say, Llama models or something else, another LLM, then you need to use Light LLM. Once you install all that, then you need to set the API key. Here we are using Gemini 2.5, so we need to set the Google API key. And how to set it, I have already shown that in one of my previous videos. Now let's see how to build the MCP server in streamable HTTP protocol. So here first you need to import fast MCP as we are using that, and sentence transformer for embedding, ChromaDB, and these are for different types of files like PDF and Excel and Word doc, right? So you define the MCP, create the MCP server here, define a path where you want to install the ChromaDB. Here, since we are using Google Colab, so we'd be saving it somewhere in one of our folders. So I basically would be saving this in this folder, right? As you can see it in the vector DB. So one folder has been created and vector DB would be saved in this folder. So let me now show you a couple of tools how you need to code it. For example, the first tool that we have is to list the RAG repos. So you need to put a decorator here at the rate MCP tools, and then this is the Python function that you define. Within the doc string, you define what this function is supposed to do. That way it helps the LLM to understand the function. And then here you define the client, initialize the client, and then client.list collection. That is how you get all the collections, and then you are returning back. Right? Similarly, the second tool that we have is the info about a repo. You define the key aspect of that function within the doc string. Then you use get collection, right? And you pass on the repo name, which you pass on from your agent. And so once you have the collection, then you return the list of files. That is how you get the repo. Then you have the create repo function again here. Decorate that with MCP tool. Define the function create rag repo. You pass on the name of the repo as the input. Within the doc string, define what you want to do with this function. Then here the main function that you have is after creating the client.create collection. So that would create the collection with the repo name that you are passing on, right? And then you pass on a message whether it is successful or not. Similarly, for delete function, you define the MCP tool, put the description within that doc string, then you use delete collection with the repo name to delete the collection. And then you have the function add, where you need to call the sentence transformer with the model that you are using. This you can download whatever model you want to use for your embedding, and then you save in your Chroma the path that you have defined, right? And here, as you can see, depending on the extension of your file, if it is PDF, you need to read it differently. If it is a document, you need to read it differently. If it is an Excel, you need to read it differently depending on the extension of the file. So at this moment, this can handle PDF, docs, TXT, XLS, Excel file. That is what it can support. Size is 1000. So basically it is around 1 page kind of chunking that it would do. And then it would save it into the vector database. And similarly, the delete document, and you use the collection delete for deleting the file. And finally, this is where you set up the transport protocol. So since it's the HTTP protocol, as I was telling, streamable HTTP, so you need to here you give the port where you want to run. So here we are running this server in port 9000, and this is the endpoint that you need to define. And here the transport would be HTTP. In the other example that we had, if you're using STDIO, then the transport would be STDIO instead of HTTP. So this is how you basically create the server. And if you are using Google Colab, then you would have to run this to start the server. You can save this into a file, and then you use the Python command to run the server, which you can also do it from a terminal. Here you have the terminal, so you can go to the terminal and then can run it. If you see here, actually I am already running it. So it is running on port 9000. So I'm using the terminal to run this server. Yeah. So that is on the MCP server. And next is the ADK agent. So again, this ADK agent, you have already seen that before. So you need to use this particular package. This is for STDIO. If you are using STDIO protocol, here I am using streamable HTTP. So you need to import this, and then you need to this is where we are using that, how we are calling that MCP. So as you remember, I was running it on 9000 port, and I'm using the endpoint MCP. So this is how you call set the MCP for in your agent, and then below where you have defined the agent, there you need to use that as a tool. So MCP rag MCP toolset is the name of the tool, and this is where we have defined it, running on 9000 port with the endpoint MCP. And this is important. This is HTTP, right? Now, if you similarly, if you are running it in a STDIO, then the command would, instead of this, you need to use this. And in the agent, while defining the root agent, this is the name of the agent, and then here within the doc string, you describe what exactly your agent is supposed to do, with what the capabilities it has, the available tools that it has. All you should put it here so that LLM can understand what this agent is supposed to do. And finally, you define the tools. So we have covered how to code the MCP server and how to code the agent to call that MCP server. In the subsequent video, I would also show you how to use a custom-made UI if you want to use Streamlit as the UI instead of using the default ADK UI interface. So I'm stopping this video here. See you in the next video.